Okay, on to tornado formation. Now, like I kind of said about lightning, scientists are continuing to gather information about the formation of tornadoes, and quite frankly, they're kind of hard to study. They're harder, tornadoes, as you might imagine, are harder to study than hurricanes. Hurricanes last longer. Tornadoes, heck, they don't necessarily even know where and when they're going to occur, so you can go over and study them, although we have some ideas. For instance, if you're wanting to kind of hedge your bets on where a tornado will form, you might look at cold fronts and dry lines, okay, that are creating these squall lines of thunderstorms. You might look within mesoscale convective complexes for tornadoes to form. We're going to see here in a minute that we need something called, I mentioned earlier in this chapter, a mesocyclone. We believe is that's kind of that rotation in the core of a thunderstorm cell that we believe needs to be in place, or they do, in order for a tornado to drop down from it. Supercells, we talked about, kind of that's your extra unstable sort of thunderstorm cell that has a sufficient, great supply of moisture and instability. Oftentimes we can get tornadoes from supercell thunderstorms. Within a tropical cyclone, now that's actually the next chapter of material we're going to be hitting, and tropical cyclone in our neck of the woods is called a hurricane. Within hurricanes, I'll just go ahead and kind of give you a heads up. If this is like a satellite image of a hurricane, these are the spiral arms. Embedded within the spiral arms are, excuse me, or I should say the spiral arms are created by thunderstorm cells, a bunch of thunderstorm cells around creating the eye wall. And these thunderstorm cells can, of course, bring tornadoes. So we kind of know where to look. In our neck of the woods, last thing up on this slide is our tornadoes, though, when we need to be most cautious is the late afternoon to early evening, 3 to 8 p.m. is when tornadoes are most likely to drop down from our thunderstorm cells. Not always. We definitely have our fair share of nighttime tornadoes. I think was the Iowa City tornado. It seems like they've been hit a couple of times, and I think it's been when the sun had gone down at nighttime. But here's a figure from your textbook showing you that the aftermath of a tornado outbreak in 1984, and in February 26th, and 59 people lost their lives. I mentioned a funnel cloud, and a funnel cloud is kind of I think of it as a precursor to a tornado, or a tornado wannabe, or the tornado is kind of dying away and you get this funnel cloud that doesn't reach the Earth's, the surface of the Earth. This slide goes ahead and says, well, why do we see a funnel cloud or a tornado in the first place? And that wind has to be moving stuff around, and it can be moving debris around that it's picked up. Cows? No. It can be moving dust and things like that. It can also, within that cloud, within that circulating air, we can have water vapor condensing, so we see it, just like we see a cloud in general. Tornadoes are almost always cyclonic. Remember that the Earth's surface, then we have a low at the vortex of the tornado, and it would be going, oh, did I do it right? Yeah, counterclockwise. There's my tornado. Tornadoes generally, a good diameter would be a mile wide. I don't know, that seems kind of wide. That's what my slides say. How long do they last? Well, just kind of putting something down, 30 minutes. And again, that seems kind of long for a tornado to last. So this is a good shot of, and I want to remind you of the idea of a wall cloud. This one looks kind of slanted, but what I've drawn around, to me, and I would probably need to see the rest of the kind of base of the cloud to make that judgment call entirely, but it looks like a wall cloud, and of course here you see the tornado and you see it interacting. Check this out. Look at all that debris being thrown up. Now, tornadoes, and I mentioned this when I brought up the Joplin photograph of that wedge tornado and the Joplin tornado. It's possible for a single tornado to have multiple vortices. And basically you have the mama tornado or the daddy tornado, and then you have little suction vortices within that tornado. I'm going to show you a picture here of that. I went to the spotter training again this year. Great experience. Put on by the National Weather Service, and they again said the more they go ahead and evaluate the destruction after a tornado, the more they are seeing or understand that a lot of times tornadoes will have these multiple vortices. So it looks like this, where this whole big thing is the major vortice, the tornado, and within that you have these little suction things. And so you can almost kind of see how the damage you can kind of see from the aftermath what the damage might look like if you have these little destruction things going on. Notice the direction of movement, of course, is counterclockwise. So yeah, this is my out. I'm not going to on your test ask you to describe in detail the formation of a tornado. The only thing that I might talk about is something called a mesocyclone. I don't know, in my test. But the formation of a tornado, of course, they are associated with cumulonimbus clouds, thunderstorm systems. And, oh, I told you, I think 10 or 2 in 100, but it's only for every 100 thunderstorm cells, only one of them will generally spawn a tornado. Now, if you're like me and you kind of track the news and what are they saying this year is supposed to be like with regard to tornadic activity, already this spring 2012 we've seen a fair number of tornadoes, and I kind of hear different sides of this with regard to La Nina or El Nino, but I have heard that La Nina kind of favors the formation in general of tornadoes, and we are coming out of a La Nina right now, going neutral probably, and entering an El Nino then kind of late summer. So I don't know what the season will bring, but we can oftentimes experience a shaft of hail or a bunch of hail falling before we see a tornado. And the reason for this is hail is actually suggesting we have a strong updraft and a good healthy downdraft when we see hail. And it's that strong updraft and downdraft that actually needs to wrap around each other in a mesocyclone, I'm going to show you here in a minute, that we get our tornadoes from. So again, I already kind of shared this information. Now don't hang your hat on it, but in general, we get our peak time to get tornadoes would be late afternoon into early evening. Okay, so I think this is a repeat slide. Okay, maybe, maybe not, just to kind of revisit it. Where our tornadoes going to form? Well, they're going to form where our thunderstorms form, and that's going to be a line along fronts, cold front or dry line, squall lines, a bunch of thunderstorm cells, all kind of part of the same system, mesoscale convective complex, supercells, and we said within hurricanes. We definitely have our thunderstorm cells. Put TS over here. Anytime you have thunderstorm cells, you might get a tornado. So here is this presence of a mesocyclone. Now I know I mentioned that earlier in a lecture for this chapter, but that's, and I called it kind of the core of a pineapple. That's that kind of within the cumulonimbus cloud we have, and it would be going counterclockwise. This is my mesocyclone. And if you're listening to these slides in order, you heard me talk about this is where we get our updraft and our downdraft that get to wrap around each other. So this is kind of showing you the formation of a mesocyclone. So this is our pineapple laid horizontally. And so I've heard this described, if you take a pencil and if you kind of rub it between your two palms, that if you have a fair bit of wind shear. So the winds are getting strong pretty quickly as you go up in elevation. You can kind of get that sort of roll of horizontal air. And then that roll of horizontal air can be lifted up by an updraft. And that same updraft is, of course, kind of creating our cumulus stage of our thunderstorm. So then finally, you can get the updraft to basically push the rotating air that was rotating horizontally, now it's rotating vertically. And this is our mesocyclone. And this is what can wrap around our updraft and our downdraft. Okay, notice the anvil up here. So it's not like a flat base to the, like the lifting condensation level, not like a flat base to this cloud necessarily down here, but boy, can you see the wall cloud. I wonder if this is the same. It kind of has that flare sort of look to it. And if you look really closely, you can kind of see debris being thrown up there. So I'm hoping by now you've heard the term wall cloud enough. Now it's hard to, it's a perspective issue with this image. You know, we can't see it, but it looks like a wall cloud. And what the spotter training folks will tell you to do is basically look for rotation counterclockwise as you're looking down at it. So what they're wanting as the National Weather Service to kind of warn other people is they're wanting to know if these wall clouds are out there, if they're forming, and actually, you know, are you seeing anything drop down from the wall cloud? Now, there's something called Scud. I haven't mentioned it yet, have I? But what Scud is kind of a look-alike to a wall cloud, and there's no rotation, so it's kind of like miscellaneous clouds that are kind of in this form of a wall cloud, but they're not rotating. So this is a good figure to kind of just summarize what we've been talking about with regard to thunderstorm cells dropping down associated with cumulonimbus clouds, and it's just a good summary.